Hi everyone. So my name is Sergey Karmalsky. I work at 4A Games, and I'm doing the art direction thing there. And we have released Metro Exodus with RTX like a month ago, but we've been working with the tech for more than a year now, and we, as you can see, but we have something to share. And the reason basically I'm here, it's a programmer dev tech talk, right? And I'm an artist, and I'm just showing how it's gonna work from the production side, from the content production side. I will tell you our team's experience. Also, I will be showing you pictures, and hopefully that will be slightly entertaining. So, a little bit of history. So we've released a demo about a year ago, and we've been really happy with the technology. We've been really happy with our achievement at that time. But unexpectedly, there has been some concerns from the world. We started seeing those reactions. Is there really that technology is worthy? And weirdly, those concerns were also inside the company as well. We already had quite a lot of working solutions, proven solutions for ambient occlusion and for GI. Like, for example, the SSAO does AO, obviously, and we had the voxel GI working, doing the reflexes from the sun. And so why bother? We also know, and basically all developers know, how limited those options are. And we even got used to them somehow, I don't know. We cannot really do proper GI. We only can bake it, so it's not a real-time solution. And the SSAO itself, it just suffers from its screen space nature. So you will always see that problem with edge fading, and you will have no data behind objects, and that's really a problem. Another problem with the SSAO is that it's mostly limited to a short ray distance, and weirdly we got used to that. But really, 1 meter is the best we can do. It even gets expensive at that, and effectively in large scenes, in canyons, in cities, that's like an edge trace effect, and I'm really not really happy. So I know that that's not the proper way basically to do occlusion. And then we met those insane possibilities with crazy numbers. So we are right now playing with ray lengths which are 50 times longer, and we are getting unbelievable amount of those rays per second. And also, what is also really important, that we are getting the pixel perfect details. So we are not limited by the scales of the scenes. And this is an example of the same street scene, and you now understand what I'm talking about. So I'm talking about large scale occlusion and large scenes, and that's really important for me, obviously. So no more edge trace effect. You are getting the proper large scale occlusion. And another example is this natural scene. You can really feel you're located deep in the canyon, and thanks to proper SKYLIGHT occlusion. And this one example is a small scale scene. And with fixed ray lengths, we are not really getting all those details when we zoom in into something. So any super close interactions, they will be lacking that proper AO. And this is an example that the ray traced GI now what allows us to have. So you can see how objects are grounded, and you can see how objects pop up from the background. So everything is much more readable now. A revelation I had is that the SSAO and the ambient occlusion path is no longer actually needed. So we've been doing that, we've been multiplying that on shadows for so long that I got used to that so much that I thought that it's happening in real life. But no, 20 years ago we've been playing with the first implementations of radio OCT rendering and stuff, and that's the proper way to basically calculate occlusion. So right now that all is happening in real time, and no more multiplication of that buffer, AO buffer, is needed anymore. So this happens properly by GI occlusion, right? And you can see in this, and this working, luckily works. This animation, there are no direct lights here. You can only see light coming from the sky. And the sky is basically HDR picture with some areas that are brighter. And effectively, that type of solution produces shadows. So the ambient occlusion itself is no more. These are real shadows. That was crazy for me. The next step, obviously, we had to go on and do the GI from light sources. And this is an example of how light sources, the sun specifically, have been illuminating interiors, and we've been getting GI only from the light probe. So the room here was capturing some proper amount of light that entered and illuminating that room naturally. So it looks just natural. It was filled with natural amount of light. But the ray trace solution is giving an absolutely different result. So in terms of overall brightness, the pictures may be the same, but in terms of detail, you can see the difference. You can see the small scale. On the very right, there is a box on the top, and you can see how light is reflected from the bottom of the window. And all objects, really, they pop up. And it also feels like the objects are related to each other, because you are getting that existence of a neighboring object visualized by light reflected. We went on, and as always mentioned, we had to go for the specular GI as well, because obviously the PBR techniques are requiring the specular pass. Requiring the light from the specular, and sometimes it gets up to 50% of light through specular, and not mentioning even metals. And the color bleeding itself is a great way to basically demonstrate GI itself. So without color bleeding, at some point we didn't feel that the reflexes were there. So basically, when materials they share their color property, that's clearly visible. And an example, so color bleeding off, that's actually no ray trace happening is here. But the image was quite okay for people. So when the first time they saw this image, they was thinking, is this RTX on? Nope. This now is RTX on, and you can see all the small occlusions, all the light bleeding effect, all the color bleeding effect. So you can see the blue and the red, and everything looks fine. So when you go back to that image, you understand that you will not want to go back from RTX anymore. And besides the implementation of the technology itself, we had to do quite a lot with the content itself. And obviously, the RTX solution was slightly different. At some point, not slightly, but really radically different. We even got some feedback on that, negative feedback. And we had to fix the scenes to make sure that they will be properly working under the ray trace solution. And we had to remove all the fake lights. So they were not working properly anymore. So all the artsy stuff, all the gameplay comfort lights, they had to be removed. And because the RTGI been bringing in its own light over there. And we also had to adjust the standard version itself in cases when the RTGI been given the radically different result. So we had to bring those two versions together. And what's also pretty important, even though we were quite excited with the tech, we couldn't allow ourselves to overplay with that, just because in further comparisons, we didn't want any version to be a loser. So both needed to look really good. It's basically Metro versus Metro. And then this happened. It's a deadline that always happens, so we just had to get drunk. So basically, all the work stopped, even though we did work on some patches, but we have successfully released the thing, and I'm pretty happy with that. And about those concerns, and we are pretty fed up with those, frankly, and it continues to happen even after the game is released. So we see that people are trying to judge if the technology itself is doing any better for the picture. And we've been doing the same initially, but we understood clearly that that's not just the right way to do. So we are getting a different result, and that result is realistic, more believable, more natural. So I suggest the word convincing. So which result is more convincing? And an example. So many people thought that this is an image with RTX on, but no, until they saw the more convincing result. So how do we use this? So basically, we're happy with an achievement, and that happiness this didn't fade off yet. We also are happy with the fact that RTX does everything dynamic and doesn't require any pre-stored stuff, because doing dynamics is just one of the pillars in 4A games. We don't like pre-bakes. We just hate those cuffs of static stuff, static data. We are also using this tech in development, and we're using this as a lighting reference tool. And specifically, we check first what RTX gives us, and then we continue with developing the final lighting in scenes. That's a pretty useful thing to do. Sometimes it even brings us random ideas that we didn't expect. Like, for example, this here, I've been making a screenshot of our Anna character, and I've been playing with an idea of doing a dark silhouette with contrast light and a rim lighting behind, until RTX showed that the result the feature is absolutely different. You can see here that the character lights herself up from her own reflexes and from the reflexes from the weapon. And that's something you don't really think of first when you're creating some imagery. And what's next? These are basically, half of this is not dreams, so half of that is something that will be available quite soon. Oles has already been showing you the working demo of polygonal lights, which are actually casting those soft shadows. That's really amazing. We're really playing with that right now. And I really hope that at some point, the ray tracing thing will solve a lot of our problems. We have a lot of ad hocs, all developers basically. They have a lot of rendering ad hocs, and all those are causing some conflicts maybe, or that you have to solve. And I hope that the ray tracing itself will fix that, will help us with that over time. And finally, I hope that at some point, the RT thing will get on consoles. You all know that PC is a trendsetter, but consoles are standard keepers. So we need that on consoles. Please, if developers are here that are working on that, please bring it. And we'll have yeah. So I'm done basically. I'm close to the final slide.